ATAL FDP on healthcare and medtech, AI and its applications. The speaker for today's or this session is Dr. Shoptorshi Goswami, who is an assistant professor at Bongobashi Morning College in the computer science department. He was also the digital transformation lead for IT and TI Cell, Higher Education Department, Government of West Bengal. He has been teaching in many renowned educational institutions, such as the A.K. Chaudhary School of IT, University of Calcutta, the IVATE Prefectural University, Institute of Engineering and Management, Salt Lake. Besides his academic experience, he has also a great number of years in industry. He has been working or he has worked in reputed organizations like Tata Infotech, PwC, and Cognizant Technology Solutions. He has written more than 40 articles in various journals as book chapters and other paper conferences, and he has guided more than 15 research students throughout. Today, Dr. Goswami will be speaking on a very, very relevant topic, AI-based interventions for cancer. I would warmly welcome our speaker for today's 12th session, Dr. Shoptorshi Goswami. Sir, please begin your session.
Yeah, am I audible?
Yes, sir, you are audible.
So, Dr. Ghosh, thank you so much for your kind introduction, and I also thank FIEM for participating in this ATAL program. So, this is really a great way to conduct FDPs. Okay, so without taking much time, I understand this is a Saturday and maybe not the best time to uh, go through new topics, may not be, but let us see, like how far inroads we can make. So my focus is going to be breast cancer. Okay, and let me try sharing my screen. Just give me a second. Yeah, so it's online now. Let me just share. Yes. So just bear with me. It is coming up. Uh, if one of you can please respond that it is visible.
Yes, yes, sir, it is visible.
Okay, okay. Uh, okay. So let me go ahead. Dr. Ghosh has very kindly introduced me, but here are some quick things. So it is just for your future reference. Uh, so one thing I would like to tell you is that we conduct as part of Society for Data Science. We do a conference called as ICDMI every year. So we are turning 10th this year, right? So we are in double digits. So I'm one of the conference chairs, and it is going to happen in St. Xavier's College. Okay, I warmly, welcome you to take part in the different programs there. Okay, so without further delay, let's now move on to today's presentation. So I have thought of that, we can keep kind of four sections here, right? So first we'll look at some details about breast cancer. Then we'll move to like basics of AI, focusing on the part that we discussed in the breast cancer. We look at focused AI interventions, okay, and then research. So AI interventions and research has some, overlapping areas, but I think nevertheless we will be able to appreciate that. So just give me a second. Yeah. So yes. Uh, all right. So these are some of the compelling numbers. So it is of 2022. Now the number maybe more. So 2.3 million women worldwide were newly diagnosed with breast cancers. 23 lakhs new diagnoses. Okay, and in 2022 itself, there were around 6.7 lakh deaths. Okay, because of breast cancer. Globally, it's the most commonly diagnosed cancer in women in 157 out of 185 countries, right? And by 2050, new cases are projected to increase by 38%, death by 68%, with about 3.2 million new cases and 1.1 million deaths expected annually. So, I mean, this probably tells you that why this is such an important issue right now. Okay, and this I have taken from Institute of Breast Disease, Kolkata, with whom we have a collaboration, which I will detail when I go to the research section. So they note, okay, that breast cancer is now the most common cancer among Indian women. Yet the system designed to detect and treat it still fails most of them. Okay, and also it went on to point out that while at a country like US, 95% of the patients have a survival period of 5 years from detection. But in for India, that rate is around 65%. Okay, and that if you take overall, but if you go to rural, because India has a lot of diversity. Okay, that figure actually goes to less than 50%. And the predominant reasons are late diagnosis, the care is fragmented, okay, standard protocols are often not followed, and then sometimes it is inaccessible or unaffordable treatment. So treatment is more costly. Okay. So when we go to basics of breast cancer, you'll have to really understand the domain of it, because for any AI area, right? So the understanding of a domain is very important. So you need to know the anatomy and types of breast cancer. Okay, the risk factors, uh, so there are several stages which we are going to discuss. Okay, from self-identification, then diagnosis. Diagnosis has several phases, then treatment, and so on and so forth. And then there are some traditional detection methods like mammography, ultrasound, and biopsy. Okay. And when we analyze that, when people are working on AI intervention, okay, AI-based intervention, so these are some of the prominent algorithms that are being used, right? So you have one hand CNN, which is part of neural network, or you have SVM and random forest, okay. So these are some of the important things that came out, right? So with that, let us quickly, review about AI. Okay, because when I talk about these AI methods, we need to put into perspective that where these methods actually fit. And this section, we'll cover pretty quickly because many of you may be knowing. And this picture, any AI enthusiast, this picture is in their memory. Okay, the 10 founding fathers of AI. Okay, mainly it was uh, John McCarthy's initiative, right, to have that famous Dharma conference. Okay, and one of the thing we need to relook is that today also today's session what we are talking about is AI interventions in cancer or breast cancer, right? So there can be many technology inventions. Please listen to this very carefully, that there can be many technology interventions, but that may not be an AI intervention. So we somehow also need to understand, right, what interventions come under AI and what intervention doesn't come under AI. So it's not that it is very important from a practitioner's point of view, because practitioners would be focusing on solving a problem rather than understanding, okay, this is AI, this is IoT, and so on and so forth, right? But from a academic angle, as we are focusing on AI intervention, we should try to understand the boundary. Okay, and whenever we try to look at AI, one of the things that challenges us is how to define AI, right? And the reason, the dilemma comes from this fact that we cannot define intelligence itself very well. When we can define intelligence very well, we can add an adjective and try to define it, right? So this is one definition that you see over here, okay, which is a what I would say very pondered definition. What it says is that if a machine can perform intelligent activities, okay, then we say that machine has artificial intelligence. Okay? So actually there is a longer definition. So it's like if an activity, okay, performed by human is considered as an intelligent activity, and a machine can also perform the intelligent activity, then the machine has artificial intelligence. As example, a man is sleeping, right? So you can make a program sleep, but that's not a intelligent activity. That will not be considered as the intelligent activity. But when probably the man is maybe solving some maths problem, okay, or maybe playing chess, right? So that's an intelligent activity. And if I can have a program which can do this, mathematical problem solving or this playing of chess, then I will call that machine actually has or possesses artificial intelligence. Okay. Now there is also, one distinction between symbolic and sub-symbolic AI, and this is also, I really want you to remember. So, there are some part of logic, you can express in terms of letters or expressions, right? You can write them down. As example, right? We were talking about chess. So many newspapers actually analyzes important games, gives you certain kind of moves, certain kind of puzzles to be solved, right? So you can express a board position in terms of symbols, and you can also express a move in terms of symbol, and which probably applies for card game also, right? And when you talked about probably an intelligent game like bridge, so this is very much possible. All right. So this is the symbolic part. All right. Now let's look at the sub-symbolic part. So so the sub-symbolic part is actually when you cannot express the logic. Okay, so a human being very easily can distinguish between one breed of a dog from another, right? But if you ask him that, okay, you write it down, that how can you identify that this is a German Shepherd? Okay, or this is a mastiff or this is a bulldog, right? So you will see that you cannot express that in terms of symbols. So that is called a sub-symbolic AI, and this sub-symbolic AI has actually motivated the development of neural networks. Okay, and in context of AI, we all know this distinction. So you have AI, machine learning is a subset of AI, deep learning is a subset of machine learning, and now the AI things that we are talking about, generative AI, happens to be part of deep learning. Right? But we can go on hours debating, certain things like what are the things that are in machine learning, but uh, are or rather, what are the things that are in AI, but not considered as part of machine learning, and so on and so forth. Okay, but just keep this in mind, and I will also take you through the journey of AI so far, right? And you see, we are talking about 1950, okay, when Alan Turing actually created his Turing test. And in fact, 1942, McCullough and Pupitz proposed the first neural model, right? Where, all of computer science students should be knowing. Okay, so that's 1942. You also have something called as Hebbian learning, right? But this is one very prominent one when Alan Turing talked about Turing test, which will tell that whether a machine has intelligence or not. Okay, 1956 we already talked about. 1962 actually, there was a landmark program written by Arthur Samuels, who was also part of that founding team. Okay, a self-learning program that can actually beat a top USA checker champion. So that program could play checker, right? And then there was a Stanford researchers deployed something called as a Shaky, which was the first general purpose mobile robot, right? That can reason about its own action. Okay, and then there was this AI winter. Okay, what was happening is that AI was promising a lot of things, but there was not that amount of delivery. Okay, And we come quickly to find May 1997 when Deep Blue, the IBM's chess playing program, defeated Gary Kasparov. Okay, though we can debate that how much of that program was AI, but that was really quite a shaking moment. Okay, and then we have Roomba, which was a first mass-produced automatic vacuum cleaner. Then Stanford also uh, uh, deli delivered or prepared a driverless car named as Stanley. Okay, so all these things were happening, right? And then comes this 2012. Probably we have not mentioned it here, when this neural network showed that they can beat other competing AI methods comprehensively in challenges like ImageNet. Okay, and 2014, you see there was a chatbot which could pass the Turing test, okay, which was, of course, an important landmark. 2018, you have OpenAI released GPT-1, right? So that was the first of their large language model. And you must not also forget BERT, okay, which was released by Google, which was also one of the large language models, okay, 2018. Both of them came in 2018. Okay, and then OpenAI continued improving, and then came November 2022 when our life changed, for uh, for a long time, right? So OpenAI released ChatGPT. Okay. And then, we have done kind of a more compressed time frame where we have talked about how multimodal things have come up. Okay. Google Gemini comes and joins this race, right? OpenAI continues on multimodal capabilities, reasoning. So Meta also joins the competition, but it wants to take the open source path because that was, less traded, right? And so on and so forth. So then you have QN released by Alibaba, which is an open source platform and very effective. Some other importance are DeepSeek, Mistral, and so on and so forth. Okay. So this thing, like this kind of development has happened uh, just in last about 2 to 3 years, right? And that landed into something like this, that AI can generate such realistic text, right? So you see over here that it has written not only a Bengali text, right? But it has also generated an appropriate image. Okay, so AI has reached that level. Okay, now, this type of AI, okay, we call this as generative AI. Okay, so we first, differentiated between symbolic and sub-symbolic AI. Now, quickly also look at the difference between generative and discriminative AI. Okay, so there is a very intuitive way to look at it, right? So discriminative is like, you know, it's like MCQ questions. Okay, so there are four options, and that AI can choose that which is the right option. Okay, and generative are like answering the essay type question. Okay, so there is no standard format by which you can actually attack this particular type of AI problem. Okay, uh, so it's a very open-ended. What I'm trying to say that even if you do not understand the subject so much, by elimination, by common sense, you may be able to like solve the MCQ problem. But this essay type problem, if you do not have that amount of subject knowledge, right? So let's say you are just asked also to write something on breast cancer and AI intervention and so on and so forth. So you can very well understand that if you don't have domain knowledge, you cannot uh, actually write this essay type of question. So this is what is the basic difference of discriminative and generative AI. To give you a maybe more concrete understanding, so discriminative AI would be, that you actually discriminate between a cat and dog. So there is an image, and the image has an animal, And discriminative AI can actually identify that okay, this is a cat or this is a dog. This is cool. But generative AI, on the other hand, can actually generate scenes, right, where there is a cat is present and also a dog is present. Okay, and in the process, it can also generate cats and dogs which were not originally in the data set. Okay, so that's the power of generative AI. Okay. And now, if you look at generative AI, right, which is a subset of deep learning, right? So, what was the building block of deep learning, right? Single neurons. So, if the picture that you see on the left hand side, right? So, that's the perceptron. That's what is called as perceptron. And then, later on, like when backpropagation was invented in around 1985, and then there was this uh, lot of hardware acceleration in terms of GPUs. Okay, there were better algorithms and so on and so forth. So we started seeing structures, as you can see in the right hand side, which we started called as deep neural networks or deep learning. Right. So you have input layer, you have multiple hidden layers, and then you have finally the output layer. Okay. And deep learning or neural networks are also called as universal approximators. So, what is the meaning of universal approximator? The meaning of universal approximator is that X and Y can be connected with each other. So, X being the input, Y being the output. Okay, they may be connected with each other in any arbitrary manner. Okay, but uh, your deep learning framework can actually identify this function. Okay, so there is somewhat theoretical proof available for this as well. Okay, and what happens is that in each hidden layer, actually you find out or you discover a new way of looking at the data, a new representation of the data. So for that reason, deep learning is also often called as representation learning. Okay. And the neural networks that we talked about, you don't have like one type, you have many types. So one of them being feed-forward neural networks. So when you have a multi-layer perceptron, okay, so people understood that perceptron can only solve problems which are linearly separable. Okay, only solve discriminative problems which are linearly separable. Right? They understood that to address non-linear decision boundaries, they need to have like more layers, right? You need a kind of multi-layer perceptrons, and these are called as feed-forward neural networks. Okay, uh, you have convolutional neural networks. So convolutional neural networks actually work on images, which you would have seen in word cloud also. Okay, and essentially, what happens in a convolutional neural network is that you have a lot of convolution layers. So convolution layers are actually, you can call it as them filters or kernels. So essentially, they have the capability of uh, of looking at patches of the image and identify some features from there. Okay, so as example, I would just like to tell you that human beings can very easily can identify that okay, there is a cat somewhere because they can see maybe a very minuscule part of their tail, right? But still, from that minuscule part, they can understand that okay, there may be a cat present over there. Okay, so convolution neural network actually works on that fashion. It looks at different patches like human eye works, right? And then it tries to extract features which are important. So let's say I have a wall in front of me, but on that wall something is dark. Right, so I don't look at the normal wall structure texture, but I look at what is dark over there, right? Then comes recurrent neural networks. So recurrent neural networks are neural networks, okay, which works on sequential data. Okay, the most prominent type of sequential data are your language data and your time series data, right? So I hope you understand time series data, right? So if I am using a sensor and not trying to take the humidity, okay, for some time interval, so that will give me a time series, right? I can look at stock market data. That will give me time series. Okay, I can look at sales data, that will give me time series. I can look at mean speed, that will give me time series, right? So any phenomena that is being observed in terms of numbers and which are time interval, right? So that is a sequence data, right? And as I say, that language is also a type of sequence data where uh, RNN started showing a lot of promise. Okay. Uh, so focus on the term recurrent. So we have like computer science students, even mathematics students have earlier must have like read about recurrence relation. So it typically, Fibonacci series is a recurrence relation. So Fn is Fn minus 1 plus Fn minus 2, right? So in recurrent neural network, uh, so the word that is going to come next is not only dependent on the last word, but maybe previous two, three words, right? So you are dependent on your previous words. That's why this recurrence term is coming in, right? Okay. So like it's not like the Fibonacci series, it's a neural network, so it can actually solve very non-linear recurrence problems. Okay, so it may not have to be linear and homogeneous, right? Okay, and the recurrent neural networks actually had a kind of problem which we call as vanishing gradient problem. Those again are like who study neural networks, they know that a neural networks, right, learns when I say learn, I mean that it learns the optimal weights of the network, right, by back propagation, right? So that is something we know. And back propagation essentially follows the chain rule of derivatives. So what happens is that, the last layers of the neural network, right? So there are, there is only a few derivative terms, right? But as you move to the starting layers, there are a lot of derivatives which are multiplied, okay, which actually results into a very small number, because typically, if you would have used activation functions like tan h or sigmoid, right, the derivative values actually come between 0 to 1. Okay, so if you multiply such small numbers, what happens is that the derivative at the starting layers become very small, and learning rate is actually proportional to this. So as a result, learning happens slowly. So the gradient actually vanishes. Okay, so that's why it is called as vanishing gradient problem. And LSTM kind of partially solves it. Okay, LSTM also had lot of problems. So one of the problem I'm just going to focus is that LSTM would operate in a very sequential manner. So, you are doing a English to Bengali or English to Hindi translation, right? So let's say I am saying, how are you? And then তুমি কেমন আছো or তুমি कैसे हो? So it will look at how, right? And then, or it will process how first, then it will process are, then it will process you, and then it will give tum, and then again, it will process how are you, tum, then it will give kaise, and so on and so forth, right? So that's how very sequentially it works, and you can understand that that can really become a bottleneck, right? That will definitely become a bottleneck if you process a large amount of data. Okay, so that's something transformers solved. Transformers actually did two things. One is that it can do this in parallel. Okay, and transformers also have another capability called as attention. So meaning, in very simple terms, that when you are translating "How are you" to "Tum kaise ho," so you are you are attaching "How" to "kaise." You are not attaching "How" to "Tum," right? So when you are translating, you need to pay attention to the relevant part. So transformer actually fix this part of the puzzle. Then you also had generative adversarial networks. So this is a particular type of network which came into prominence around 2018-19 because of their amazing capability of generating realistic images. So when all these deepfakes and things were happening, so the predominant technology that was being used is GAN. And I will encourage everyone to read about adversarial machine learning, that how you can have kind of two agents which are having complementary goals, right, and conflicting goals, and they can be set up in a game theoric environment to improve the system, right? So this is very much possible. Okay, autoencoders are actually a sophisticated cousin of principal component analysis. So if you remember that we can actually do dimension reduction by in terms of PCA, okay, and PCA actually can only look at it very linearly, right? But autoencoder has this capability of finding the nonlinear relationships out of this. And then you have also graph neural networks. So this is something a lot of researchers are working on. So there are some what I would say some data which you can very easily express in terms of graphs. As example, that can be your friendship circle, right, in social media. So that's a graph, right? Or we are talking about some relationship between genes, right? So whenever we have some kind of a relationship, okay, so we can use graph neural networks, right? And now, if we come to quickly large language models and what is happening over here, I'd just like to point out two things. The first thing is that I told you that generative AI is essay type and uh, your discriminative AI is MCQ type. I think you have understood the difference, right? Now, LLM of course comes under the generative AI section. Okay. However, generative AI also follows kind of a MCQ. How? That instead of trying to understand or trying to answer a question, what it tries to do is it tries to predict the next word. And the next word also can be thought as MCQ options. Please understand this, right? And you get the right one, then you take also as an input, then you try to again predict the next word, and so on and so forth. And actually, you'd be surprised to know that the most famous model, which is GPT, is actually trained on next word prediction, right? And whatever you can see this information extraction, instruction following, object recognition, image capturing, sentiment analysis, whatever we are seeing as an application area of large language model, okay, so these are all called as emergent capability. So the model was actually not trained for that. Okay, so as example, that you may like you may learn swimming, okay? But as you learn swimming, it may so happen that you have some difficulty in walking, but your walking improves, right? So you are not trained for that, right? Or you can think of probably some other things, right? But when you have tried to learn something else, right? But in the process, you have ended up learning something, okay, which was not at all expected when you started the task, right? So that's what happened in case of large language models. Okay, and why it is called as large language models? Because two counts. The first count is these models are large. Why that? Because they have large number of parameters, right? The initial models were only having trillions of parameters. So now, the march is on, right? So we are close to, or probably we had broken the 1 trillion parameter thing also, right? Uh, Very possible. That's one part of the large. The second part of the large is that it is trained on large amount of data, right? So how do you classify something as large or something as small? You can do that sheerly by the number of tokens that are there present in that. Okay, so when you have a large parameter size, okay, and you are trained on a large number of tokens, right? Then we call it as a large language model. Okay, and you can see that it is said that there is training and adaptation. So what happens is, so this adaptation is often called as fine tuning, right? So what essentially happens is that if you go to Chat GPT and start asking it medical questions, okay, so maybe it will not give very correct answers, right? Because it it has not trained, it has not been trained uh, on medical jargons, right? So its efficacy may not be that great, you see. So that's one thing. But now it has general, language capabilities. So if you give it, if you further train it, for a small amount of data on medical document, so it can start picking medical jargon, and that is very much possible for legal domain also, right? So we actually are doing some work in legal judgments as well. Okay. So that kinds of give you a very quick walkthrough of AI. So this is not a comprehensive overview, right? But I just wanted to touch upon the different areas of AI. Okay. So as example, we talked about support vector machine and random forest. So they actually come under machine learning. Okay. Then we talked about CNN and transfer learning. So they comes under deep learning. So that's the kind of basic idea that I wanted to give you. Okay. Now let's come to AI interventions in breast cancer. Right. So we are already in our third topic. Okay. So essentially, if you look, right, probably I mean there may not be a complete agreement, but starting from the detection, okay, to the treatment planning, you can broadly classify the journey into 5 stages. Okay, so these 5 stages are something which is going to, remain with us for quite some time. So that's how, we are going to weave our discussion. The first step is, self-detection or routine check that, you generally after certain age, right, you go for, routine blood test and then a routine checkup by doctor. So that is one way. And then you may, the self-aware people, they can also see that, okay, there may be some lump or some pain or some nipple discharge, which is irregular, right? So, they go for a doctor, right? A doctor's visit. So doctor then physically examines, right? So, which is called as clinical breast examination, okay? And then she may be subjected to further test, right? So it can be mammography, it can be ultrasounds, okay? And for some time, it may be MRI as well, okay? Uh, and please understand that, this is just for an indicative process, right? So it also depends on, what kind of hospital, what kind of healthcare facility you are in, right? So if you're in a rural area, there will be a lot of focus on clinical examination because you not have the facility as well as the pocket to go for expensive tests and so on and so forth. And then you go to biopsy. So biopsy is like for the sanguine confirmation, right? And then you after biopsy there are lab tests, right? So in lab test, it is trying to find out that what is the type of the cancer, what stage it is, and so on and so forth. And then based on that, there can be something for treatment planning. Right. So there is also one related things which I will also discuss later. You see, we started with this that when a woman is actually diagnosed with breast cancer, so in USA, actually 95% of the patients live at least for 5 years, but irrespective of the stage of the cancer, right? Minimum. I'm talking about minimum, right? For India, that number is like 65%, and we don't have availability of data for a state level, so I cannot give you a figure for West Bengal. Okay, but these are primarily the 5 stages: self-detection, followed by clinical breast examination, imaging tests, which are like mammography, ultrasound, and MRI, then biopsy, and then pathology and treatment plan. Okay, so this is a more broader picture which we call as the triple assessment flow diagram, right? So a patient visits the hospital, right? So uh, it is broken down into different categories, right? That you have a category, okay? You have a category when like when you are seeing some irregularities, right? So it can be need additional imaging, or it can be negative, or it can be benign. It can be probably benign, right? And then you talk about management, and then you also have some likelihood. So essentially, what happens is that in a country like India, as I said, that you don't have access to a lot of quality healthcare, right? So what happens is that you try to prioritize so that the resource is optimally used, right? So you are not putting everyone in the same kind of test, okay? So even if probably that was not required, okay? So that's the thing that is being told, right? So we were also talking. I'm not very sure about this. That there are these ASHA workers, right, who are in in the rural belts, who are the like first touch points for rural citizens, right? So they have kind of a checklist which they use, and they they ask for their clinical examination and so on and so forth. Okay. And then depending upon the symptoms based on clinical examination, tests are conducted. So as I said that, tests are like ultrasound, mammography, and so on and so forth. But again, as I said, that ultrasound, mammography, MRI, all these, are used to identify, but the confirmation comes from biopsy. Okay. Confirmation comes from biopsy, and then based on the test result, different treatments are suggested. So that can be medicines, that can be chemotherapy, that can be surgery, and so on and so forth. Okay, so that's kind of the triple assessment that we talked about, right? So the first is by this kind of a checklist. Then there are different type of tests, but even here, actually, there are these histopathological tests are done. Okay, to determine this, you are also tested for receptors, right? So all these things actually happen. So that's why we call it as a triple assessment. Yeah, and now, when we come to AI, uh, 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 the first thing that we focus on is the data, right? So AI, again, like we talked about symbolic AI and sub-symbolic AI, but there is another way you can bifurcate AI, which is called as inductive AI and deductive AI. So earlier, when you have a rule-based system, right? So there are some rules in the system, and based on that, you are given some fact and you inference. So those kind of systems are actually called as deductive systems, right? So we deduce. Uh, Whereas inductive AI, okay, learns by example, right? So you see some pictures or you see some math problems, and you learn to do that by maths. So inductive AI is heavily dependent on data, and all this generative AI and all this that we are talking about, you can very well understand that this must be part of inductive AI, right? Because large language models essentially needs large corpora, which is nothing but a large set of data. Okay. So what we have now in this slide focused on is the data that is getting generated in each of these stages. Okay. So you see that when a cell detection or a routine check happens, the data that we look at are different symptoms, a symptom takes like, as I said, if there is some swelling or, some discharge, right? Then the age, family history, if anyone had earlier breast cancer, past screening reports, and so on and so forth. So, though, I mean, you may get something in a tabular format, but typically this is also those structured data, but captured in an unstructured format. Okay, and then you go to clinical breast examination. So you have now doctor notes and prescriptions coming in. So these are essentially all in text, and specifically, it will use a lot of jargons, a lot of medical jargons, right? It will also talk about lump size, lymph nodes, and so on and so forth. So it will a mixture of tabular and text data. Again, I would like to say that most of the cases you are going to get textual data, right? Then comes the imaging test, right? So you have diagram images, then you have radiology reports, you have BIRAD score, which is one of the scores which talks about the possibility of cancer in a category of 1 to 5, right? So those things are done. It goes for biopsy, okay, and then it also goes for so when it goes to biopsy, the data is the pathology side images, right? So you take out a little portion, put under the microscope, right? And there are many other things that you do. Okay, so all these are the associated data of these 5 stages. Okay, clear enough. And now we go and look at again each stage of these 5 stages, right? And I try to see that what are the AI opportunities and models that are there, right? So uh, LLMs you can use for system triage, right? So GPT style models identify red flag symptoms. So actually, there is a competition going on in part of India AI. So you must be aware of India AI. So India and UK particularly are like participating in a India UK Accelerate program. Okay, so one of the track of that is healthcare, and like I am one of the mentors over there. Okay, and there are teams where people are participating. So some are doctors, some are startup owners, and so on and so forth. Okay, and of course, you also have some technologists. So it's a fantastic combination of teams, right? Who can work and deliver a product, right? So already we had a evaluation done in Hyderabad, I think late September. Okay, and there is one more will be in Bangalore, first week of December, and then based on whichever team actually goes forward, right? So they will be presenting their case in the final Impact Summit, which will happen in February 2026. Okay, so what I'm trying to tell you is that this particular thing, the symptom trial, is such a relevant problem of India, you know, that you do not have access to experts. So in some way, if you can triage and tell that, okay, this is the more important ones, okay, that takes off a lot of burden from the system. Okay, and then there is risk prediction models, right? So based on the symptoms, you can actually predict risk that, okay, this person falls in this category, and so on and so forth. Okay, and different models that you can use is logistic regression, gradient boosting, and so on and so forth. Okay, now, when you come to breast examination, so you can uh, use NLP models to extract data from doctor's note, right? So these you can understand. So these are all assisting. Okay, so this is not something which is happening at that point of time, right? A kind of real-time intervention. Okay, so these are for future use, right? And clinical ML classifiers like XGBoost, Random Forest, right? So that can combine symptom history to predict a suspicion level. Okay, so these all are available. These all are possible. And when you talk to imaging tests, right? So the like state of the arts are, of course, your CNN based detectors, right? For lesions means irregularity. So you have YOLO or RCNN or RetinaNet and so on and so forth. And not only that, you also have like things uh, like a resonant dense net of net is actually deep classifiers only based on CNN. These are called as custom models. Okay, but even after that, you have the VLMs, the diffusion models, and so on and so forth. Okay, uh, at biopsy, you typically have whole side image, and you can apply deep learning, right? You can apply ResNet and vision encoders and so on and so forth, right? So there are a lot of what I would say there are a lot of techniques that are available over here, right? Okay, and then pathology and treatment plan. So you try to find out the receptor status because there are many ways of blocking hormone and treatment, right? So here this receptor status actually works a lot, and then another important area probably uh, not typical AI scientists look at it. It's more people who are from the statistical learning background. They work is called as a survival analysis. Okay, so you are here. So what is the chance of your survival? One question can be chance of survival. Another question can be like the period of time, right? So these are typically couple of problems which are addressed as part of survival analysis. Okay. So now we move to the final section, and I'll just like to stop for a second and ask from participants that in case they want to tell something. I will roughly finish around 5 or maybe 5 minutes before 5, so we have chance of interaction. But I just wanted to do a quick check.
Participants, any questions from your end? You can
You can
ask Dr.
also
Gosring.
yes, you can ask or
And if
you can
not,
write down also.
you can do that in the chat box also.
Yes, yes. So it's not that we can take it, we will have to take it now, right? So we can answer some of them, or we can take them later, right? You can also you have will have my coordinates from the organizers. So you can also get in touch. Okay. So let's now go to the research part of it. Okay.
Oh,
And what I've done, so research actually has two sections or two subsections. So research has some subsections where I talk about some general methods, okay, how they have worked, okay, and then I will also talk about maybe for just 5-10 minutes that something that we have started. Okay, yeah. Any question? No. Okay, good. All right. So we are starting with AI in base screening, but this is not something we have done for every phase or every stage. Uh, So in AI in breast screening, you see that this is a high disease burden uh, because breast cancer remains the second leading cause of cancer death in women. So early detection is required, right? Because it improves survival. And then mammography has some limitation, right? So despite large scale screening programs, mammogram interpretation suffers from false positive and false negative, right? So this is something you will very commonly observe from literature. Okay, and then there is also human variability. Okay, so radiologist will actually, look at or interpret things differently. And you will see that here also how AI assistant has worked. Then, of course, something that I was talking again and again in a country like India will always have workforce shortage, right? So many regions face an acute shortage of trained breast imaging specialists, limiting timely diagnosis. And here is where AI opportunity is there that deep learning and medical imaging can enhance accuracy, reduce workload, and extend quality screening. Right. So this is something it has to offer. So this is AI-based workflow that you see over here. Okay, but I will not say that this is what is typically now being followed. Okay, because now we are mostly using many deep learning and generative AI based models. So these are old way of doing things. So you will have data acquisition, right, and then you will do a pre-processing. So you focus, then you go to so what is called as ROI selection, region of interest selection. So you are not looking at the entire image, but the portion of the image that is of interest to you. From there, you are taking up the radiomics features, and then it's like a tabular data. You can apply models like SVM or random forest or KNN or logistic regression or gradient boosting based decision tree, right? Or XGBoost and so on and so forth, right? And you can classify that into benign and malignant. So this is a typical AI based workflow that is followed. Okay. And this is one of the papers I wanted to share with you, right? So, which is International Evaluation of AI System for Breast Cancer Screening. Again, the focus is screening, and what you look at the data set. So, it was a mammogram image data set, right? From UK, there were around 25,000 cases. From US, there were 3,097 cases. Okay. Uh, so there were data pre-processing and labeling done that like whether cancer was confirmed by biopsy, okay, and then follow up for non-cancer. So that way you get the label, right, true level, or you get the ground truth, okay, and then you do a deep learning based model training was done. So CNN was done on 2D mammogram views, and this is a very common practice now, right? That you do like a KBC approach, okay? So you don't involve one expert or one doctor, right? You go to multiple doctors. So in this case, you get go to multiple models. So you actually ensemble three models, okay? And it was compared with radiologists, right? Uh, Different measures that were followed were sensitivity, specificity, AUC, ROC. So who knows like how a machine learning model is evaluated? You know about this. And of course, I mean there was a very interesting thing, cross-country validation. So it was trained on UK data and tested on US, okay, which was for generalization, right? And the key finding was that the false positive actually reduced. Okay, so it can potentially, as you see, can reduce the workload by 88%. Okay. So this is one of the papers I would like you to refer. And this is also a very interesting one, utilizing large language models in breast cancer management systematic review. So this is not an approach this paper proposes, but this is a paper from 23 which got accepted in 24. This actually tells you that what are the areas where large language models are being used for breast cancer management. Okay, so you see that there are three things. First is you can do some information extraction from clinical tests. Okay, so that is where you can apply this. And next is that you can support you can get supportive clinical decision making tools in a multidisciplinary tumor board. So that is also something people are doing, right? Uh, and then it was also question answering for patients and physicians, right? So that is also some of the areas that people have got. So when I show you this, what this is trying to tell you is that this classifies that different areas where LLM is being applied. But this is also 1 year or 1.5 year old, right? Here I show you another work. Okay, probably this is the picture is little blurred. Okay, so this is LLM powered breast cancer staging from PET-CT reports, a comparative performance study, right? So can large language models accurately classify TNM stage from pre-text PET-CT reports, right? So if the PET-CT report text is available, can you actually come with the stage of the cancer, right? So there were four large language modelings that were used in zero shot context. So you know about one shot, zero shot, and many shot, right? So it is not being trained, no fine tuning, no examples. You are just asking it to classify, and it could do. So what was seen is that large language models can achieve robust performance in classifying TNM stage from free text paid city reports, okay, demonstrating high diagnostic accuracy. So this is also one of the areas where LLMs have been used. Okay. So this is an area where you see that deep learning based image classification for breast cancer subtype and invasiveness diagnosis from whole side image. So this whole side image is also called as histopathology. Okay, so this is done, and this is also an ensemble method. Okay, so we saw an ensemble method already. Uh, Improve breast cancer. So what was the goal? The goal was to improve breast cancer diagnosis from microscopic tissue slice using AI, right? So this is what is called as the histopathological site. Okay, and overcome the limitation of single CNN models by creating a strong ensemble system. So this is more from a system perspective, right? And the data set they used was called as batch data set, which has 400 high resolution pathology images, right? And it also used a data set called as break his data set, which has 9,109 images. Okay. And the what they used is VGG16 as z 50. They applied transfer learning. Okay. So to by using ImageNet weights, and then they pre-processed by using 256 and 256 patches and so on and so forth. And this was kind of the pipeline, that you have a data set, then you do a patch. So this is where actually, you have these two models getting fine-tuned, you can say. You have VGGNet and ResNet. And then, you have a connectionist layer, and then you are using that output. So these type of techniques are called as model stacking, right? So you take output of other models, and then those models which are like those outputs, or which are like proxy outputs, okay, are then again mapped with the input. Okay. Uh, okay. So this is also a very interesting thing. I came across this. So it was early detection of breast cancer in MRI using AI. So as you see that one of the thing that is coming again and again. So what are the different areas? The different areas are one is screening, right? So in screening, how can we be more accurate? That's okay. But then can some way, okay, we find out that there is a chance, right, that this will develop into cancer, into breast cancer, maybe after 6 months or 1 year, right? However, I really I will have to think and consult a lot of data right? Before I come to a conclusion that the relevance of this in India, okay. However, what is happening here is see, so these cases are labeled BIRADS 1 to 3 and diagnosed 1 year later. Okay. So many breast cancer are already visible on prior year MRI. So 1 year before MRI, right? But are too subtle for radiologists to detect confidently, right? So they won't have that confidence. Okay, they may find that. So these cases are labeled as BIRADS 1 to 3, which are like probable or something. So I don't know if I have given that right. So but BIRADS every score, what is the meaning? That's a very standard medical document. And so you need a method to identify which normal benign MRIs actually contain early sign of cancer. So the solution approach was fine-tune a convolutional neural network, pre-trained on large MRI data set. So essentially, you have a 1 year old MRI data, and then you track them for 1 year, right? So you can understand the involvement of creating such data set, right? How involved that process is. Okay, and that there was 3029 MRI scan from 910 women. Model outputs a risk score for future cancer, a slice level location where cancer is likely to appear. And then, of course, I mean, evaluate a workflow where radiologists recheck only the top 10% highest risk cases. So it's also essential because we are already talking about agentic systems, right? We are talking about human in loop and so on and so forth. So many things will be automated by AI, but some cases, when decision making is difficult, the boundary is fuzzy, right? So you actually highlight those cases and take to human experts, right? So AI predicted future cancer with AUC 0.72, which you can consider to be quite high. And re-evaluating only 10% of exams flagged by AI could detect 30% of cancers 1 year earlier. So, AI could correctly localize future cancer area in 50%, 7% of the cases. Okay. So, this is what is one other area. Okay. And as I was mentioning, that AI is also used in survival analysis. So, this is one paper that I have given. And what I've tried to do here over here is I have only discussed those papers, right, which are actually from 2023 or 24 onwards. So, you'll not get papers, or I will say that these are all published in 2024 or onwards, no, not even 2023. So they may have been submitted in 2023. That's a different thing. So uh, these actually, survival analysis, as I said, based on different criteria, different symptoms, response to different treatment. Okay, respond to other things like maybe family history, right? So you actually come to the survival analysis. So there are uh, if you see the y-axis, so most of them have survival probability. So as you see that let's say take this graph, right? Tumor grade. Okay, so tumor grade actually is telling that if tumor grade is like you are measuring in a certain manner. Okay, as you see that these are lymph nodes, status 30, lymph node status in, and so on and so forth. So it tells you that what is the survival probability. Okay, uh, right? What is the survival? How much time actually that person is going to survive? So this must be days. The x-axis is days. As I said, I know this is a very involved uh, method, okay, which you can go through. Okay, I can suggest some materials if you're interested. Okay, now, so I am hoping that after this lecture, some of my fellow colleagues will have interest to go about and explore this domain more, right? So this is an area probably the government is pushing a lot, right? Startups are trying to work. It's an important problem for healthcare industry. Okay, so one of the things that you might want to do is you might want to go and find out the data sets. So as I said, the data sets are actually backbone of your inductive AI methods, right? Uh, so these are some, these things, right? So you have a data set called as TCGA, BRCA. So you also have genomics and clinical data. So, this is also one of the trends that is happening in, a lot of places, that you are having the genomics data also available, right? So when you get gene level data, what happens is that you can actually go for a very personalized treatment. That is possible. Okay. And you look at the patient's size also. This was 1100. Yeah, then there was a Duke breast cancer MRI. So you have MRI images of 922 patients. So this was from Duke Hospital, USA. Okay, CBIS DTSM. So I believe this data is also available in Kaggle. So these are mammography images. So you have like more than 2,500 exams. These are also USA data sets, right? Then this is a very, very old data set, breast cancer, Wisconsin. I don't think this qualify for any kind of analysis anymore. But very, very interestingly, as like reviewers, we are attached to many journals and conferences and so on. So we actually receive around 5 to 10 papers each year to work on these data sets. So this is probably a 1980 data set, right? And that's also a tabular one. And then you have MetaBrick, where again you have some gene expression data and clinical data, right? So what I wanted to highlight over here is that, uh, of course, one side, you have different type of data. So mammography, you have gene expression, MRI, and so on and so forth. But at the same time, what I wanted to highlight is that there is no data set, okay, which focuses on India. Okay, so this is something we wanted to highlight. Okay. So now, last 5 minutes, I'm going to speed on what we are doing in this area, right? So this research is being carried out as a collaboration between Institute of Breast Disease, Kolkata, and I would what I would say, I would actually not uh, give you a spoiler that we have just started. So although we know we have this rich collaboration, we are just taking the initial steps. Okay. So we have started working with Institute of Breast Disease Kolkata, and I think in 3 4 months time we have started collecting data. We have collected around 5,500 patients data which have visited to clinics, okay, of IBDK during this time, okay, which spans like 23 months. Okay. The data format, so that comes from their internal IT system. So we have got Excels, but the data I probably cannot show you because of confidentiality, right? But the data, what the problem is that you have certain fields, but let's say you have a symptom field, but the symptom field also have not only the symptoms but also what was diagnosed, what test was prescribed, what treatment drug was prescribed, and so on and so forth. But, whereas you also have fields for that. You also have fields for medicine prescribed, right? So this is one of the problems. Okay, uh, all right. And this is our team. You see, so this is headed by Dr. Shomen Das, who is the director of Institute of Breast Disease. We also have Professor Kanad Basu. He is a professor in practice in University of Marshall, right, and Marshall School of Business. Okay, and we have Professor Amlan Chakraborty, director at HUD School of IT, CU, and I mean he plays a lot of role myself, and I have not given like the entire team's photo because I was preparing this quite last moment. So Aramika and Jubraj and Jashi, some bright students are working. Aramika is also is teaching in a college. So we are looking for a lot of interns. Probably we have not got given a formal call, but this is something we are going to do very quickly because there are a lot of things that needs to be done. Okay, so when we started with this kind of data set, and this is under submission, right? In some some conference or journal, I am not specifying it, and so these are unpublished results. Okay, so what initially we did was kind of EDA and tried to understand that what is the nature of the data. So as like we could see some of the places. So this is a simple word cloud presentation that some places which were more prominent than others in Kolkata were Boranago, Shithi, Damdam. So these are when I talk about locations, These are where the patients reside. Okay. Again, I mean, there is not much to interpret from here. Okay. And then what we also did was we looked at, so these also had data of male patients. Okay. And also, I would like to tell you that this is not necessarily focuses on breast cancer because we don't have anything which actually tells that this patient actually came for breast cancer, right? So we know that this is an oncology patient. Okay. So we have tried to analyze them using violin plot. So the violin plots actually tells you that if I focus on women, so this is one of the groups like 20 to 30, and then you also have a group where it is 50 to 60, where there is a prominence. Okay, there is a prominence of coming to the clinic. Okay, and we tried to answer some research question. The first question was, what were the most common presenting symptoms among women patients? So this is the first question. And the thing that we saw was, as I said, that there were a lot of misspelling. It was into some other folder. So we created a dictionary based on keywords, then also used LLM techniques, right? And then we try to find the most important things, right? So some of the things that came easily up were breast lump, right? Abdominal pain, and so on and so forth. Okay, and we also what we did was we tried to put some kind of a structure. So we actually found out the four most common symptoms, right? So which were like breast lump, abdominal pain, then swelling and bleeding, right? So these were the common uh, uh, most four common symptoms. So what we did was we did some kind of structuring of the data. So we added four columns which are kind of binary fields, okay, which will tell you yes and no, right? Which will have value like yes and no. So this was the research question one. Then we had a research question two. Do the symptoms vary between different age groups? If yes, is the difference statistically significant? So what we did was we again divided the people. Here we are talking about the woman patient, and we have not mentioned here. So when we filtered from 5,500 patients, we came to around 3,300 patients for females. So that's the scope of study for our research question one, two, and three. Okay, so what we could see is that visually we can see that there is quite a lot of difference. So 18 to 30, the most common thing is breast lump. 31 to 45 also it is common. But then when we are going to 46 to 60, it's quite mixed, right? And then 60 plus, right? So it's abdominal pain, which is the most common one, right? So what we're trying to tell is that symptoms are not enough, right? So you also need to look at the age group. So that has a this thing, and we looked like we also looked at the difference through the eye of statistics, and one way ANOVA actually confirmed that these are statistically significant. So that the difference that we see is statistically significant. We also tried to look at the co-occurrence. Okay, so we saw that abdominal pain and swelling are the most common ones, coming together, and abdominal pain and bleeding are followed by next. Okay, so this is our second research question, and the final research question that we had was, do the symptoms vary between location types? So when we say location types, what we did was we painstakingly actually uh, classified these areas into two categories: Greater Kolkata and district and others, right? So we have a lot of patients coming from Murshidabad, Birbhum, Hubli, right? Bankura, okay, Arambagh. So lot of patients are coming up. So we mapped them into district and others and Greater Kolkata. And again, we tested that there is a difference between these two groups in terms of the most common symptoms. Okay, so you see that uh, district and others, the most common one was breast lump. For Greater Kolkata, also it is breast lump, but the ratio is much lesser. So that may also, tell you like certain things. So maybe rural area you are more shy to report things, right? So maybe that's the reason it is skewed. Okay, so again, this was statistically significant. Okay, So these are some of the references. Okay, I have also given you a lot of references in terms of 5 or 6 papers that we've discussed, and you see that I have tried to cover, MRI images. All right, I have tried to cover histopathological images, and I have tried to tell you that different models that are being used right now. Okay, which are predominantly CNN-based models, and so on and so forth. And with that, I would like to thank you for patiently hearing. And if you have some questions, we have around 5 minutes, which we can explain that question and answer.
Thank you very much, sir, for that extensive discussion. There is already a question in the chat box from Dr. Shomodeep Ghosh. How accurate are AI algorithms compared to human experts? And he's given an example also. For example, several studies suggest that AI can match or even surpass human experts in specific tasks, like analyzing medical images, but performance varies. So, what about your views, sir?
Yeah, thank you, Dr. Bosch, for that question. And that question is a very pertinent one, as well as you can understand that's a very generic one. And so, right now, the role these AI assisted techniques are going to take is actually that of an assistance. Okay. So, when I talked about, I don't know if I showed you that paper. So, there was an experiment done. Okay. That radiologists, were looking at some MRI scans. Okay. And detecting that whether, there is cancer or not. And then what happened is that AI assistants were asked to analyze that, and that note is also accompanied with that MRI image. Okay, so now actually it could be seen that radiologist performance or radiologist accuracy actually improved by 10%. Okay, so we attend a lot of health conferences, and you are absolutely right. That we are talking about human lives. So unless the AI
Mm.
system is trustable, explainable, right? So the adaptation will always be very low. So it's a thing in the future still, right? So that's why we cannot just like that start a AI project. In our project, we have involvement, deep involvement of doctors, and that is very necessary because that's where the domain knowledge will come from. Okay. So forget AI matching or even surpassing human experts. So that's not the idea. The idea is that if human experts are at X level, right, with AI they should reach X plus delta level. So that's the idea.
So there is another question in the chat box.
Yes.
Oshishaba
The-
Mojumdar, if the patient is not aware of the symptoms, there will be delay in detection. How can women be aware of the same, as well as will there be a change in personality of the affected?
Okay. So that's a question. Probably doctors will be like more suitable to answer, more appropriate to answer. Okay. Uh, So I can point out to some of the breast cancer awareness camps they are doing, right? So they have launched something called as Project Team, which is covered extensively in newspaper also. Okay, so they conduct a lot of awareness camps, and from if you are representing an institute and you want them to visit and conduct a camp, they will do that also, right? So if you have colleagues, friends who wants to attend, and we can definitely connect you. They would be happy to be of help.
Thank you, sir, for bringing on board that discussion about the role that AI can play to improve screening detection and survival chances in case of breast cancer. On behalf of the organizers of ATAL FDP and Future Institute of Engineering and Management, I thank you profusely. I wish all the success for the project because it is not only for our well-being, society's well-being, but I think a great many women are looking forward to the success of the project. Thank you so much, sir. Have a very good day.
Thank you so much. Thank you so much. With all your help, we can probably make it successful. And as I said, we are very open to collaboration because you can understand that this is a task we alone cannot do. Okay, so this is an excellent forum. I thank FIEM, for making it reach to a more large audience. And anyone interested, please get in touch. With that, I will, take your permission and leave. Okay, so I wish all the best to dear participants and also to the organizers. Thank you so much.
Thank you, sir. Thank you once again.